So I'm starting the class now. Great. So the last time we did the LCD screen. So going to do a quick recap on that. So far we've done push buttons, we've done digital read and digital write. That is turning on an LED using digital signals. We've also done turning off the LED as well. We've done receiving inputs, and we've done the LCD, but then we're doing a quick recap on the LCD. So let's pay attention. Again, I'm using this side just to simulate. I'll show you how to do it in the editor. Okay, so because in your exams you are going to be using the Arduino IDE, you're going to be building the project practically. All right, so you are not going to be using a simulator. Some of you think you're going to be using a simulator, but no, you're going to be building it practically. Great. So the LCD you are to use is the LCD with I2C. So again, this is just my simulator, so I'm going to find it, so I don't need to really do much talking here. So LCD with I2C, so we're going to be using the 16:2 LCD with I2C. Great. So this is how the connection goes. Pay attention. So we have ground, VCC, SDA and SCL. So ground goes to the ground pin. 5 volts goes to the VCC. SDA goes to A4. As you can see, it's even highlighted, but then you don't have the luxury to do that in the exams. Then A5 goes to SCL. So you can use this place to practice and get familiar with everything. So let me just change the color. Great. So that's all for setting up the connections for the LCD. So let me drag this down here. Okay, so now that we have the LCD set up, we need to add the library. And remember classes, last time I was talking about classes. So a library is just a class, okay, where there are other codes, there are other methods, and there are other variables that have been declared somewhere else, and all you need to do is to include the name of that library inside your Arduino sketch. So what you see on the left side of your screen is the Arduino sketch, so you just need to include it. So I'm going to add a new library, and the library recommended for controlling this LCD, okay, is the LCD underscore I2C. LCD underscore I2C. So you select that library, and there are already ways you can use this. So first of all, you need to include the library in the sketch. So hash include, then you open a bracket, LCD underscore I2 and C, I think dot H. Is there a question? Okay, there are some. Francis.
Yeah, yes, sir. Please, are we going to allow to maybe open the hello world to copy this library, or we have to keep it in our head?
Um, you have to keep it in your head because, for all you may know, the project will be set up, and we'll just ask you to code it in maybe a notepad. Then you bring it. Then we'll run it onto that already connected circuit. You understand? For now, we've not settled on those details. So please learn it if you can. Okay, thank you.
Okay, thank you.
Yeah. All right. Obed, can you hear me now?
Yes, I can hear.
Okay. So lcd underscore I2C dot h. Then we want to create a child of that class, or the instance of the class. So we'll again mention the name of the library. Then we can so when we mention the name of the library, then we can now call it whatever we want. So let's say Kofi, right? So Kofi, and Kofi is going to take a number of arguments. First of all, it's going to take the address of the library. Yes, so I'm typing this from my head because I've practiced this for some time and it's part of me now. So with practice, you will also get all of these things in your head. So we have Kofi, that's now the name of the instance we have created. Then we have the address, then we have the column numbers, and we have the row numbers. So the LCD, the 16 by 2 LCD, so 16 means 16 columns and 2 means 2 rows, right? So in our void setup, we need to get a few things set. So in our void setup, all we will need is, let me try and make this bigger. For now, we don't need the okay. All right. So in the void setup, we need to there are certain methods inside the lcd underscore I2C library that need to be called. So, and now we don't have to mention this whole thing to be able to use it, but all we need is the child's name. So the child is Kofi right now, so we would say Kofi dot begin, and this begin does not take anything inside the bracket, right? So it ends there. Then we need to turn on the backlight as well. So Kofi dot back hope I'm right, backlight here, right? So let's run this code and see what happens. So I'll click on start simulation, and as you can see, the back of the screen is lit. Okay, if I was to comment this line 6, right? If I am to comment it, all we'll have is the light at the back is now off, right? Which it makes visibility difficult. So I'll just leave it as it is. So now if we want to print something, let me stop this simulation and close this. So if we want to display a message, right, we'll do, don't get
Please, I can't
confused.
see the board. Okay, I can see it now.
Please, sometimes it may be your internet giving you problems, right? So unless maybe you ask from your friend and generally you cannot see it, then you talk. Okay, thank you. So it's not always going to be lcd dot maybe print, okay, because our child name is not lcd but Kofi. Do you understand? So I am expecting, or you are expected to bring that kind of dynamism in your code, so that we won't see lcd dot print throughout, or else there will be a suspicion that you guys have copied. You understand? So it has to be dynamic, because it's only someone who doesn't know how to create a child from a class that would go and copy, and that person will put lcd there. Meanwhile, the child is called Kofi, and you'll be asking yourself, why is the code not working? So please take note. So Kofi dot print, and I want to print out maybe hello. Again, I'm doing this in the void setup, so watch what is going to happen. Let me end this. Then I'll run or start the simulation. So as you can see, hello has printed, but because it's in the void setup, it ran just once and that was the end. So another thing, another important method to know, okay, is the dot clear method, okay, or the clear method. So Kofi dot clear. So what it does is that it clears the screen. Basically, it cleans everything that is on the screen. It doesn't choose what it should clean, but it cleans everything on the screen. So if I restart the simulation, you realize that Kofi will print. Then so I think you saw it. Kofi just printed and the screen has been cleared. And because it's in the void setup again, it's going to run one. So the end of it all is happening because I don't have anything in the void loop. Hope you can see. So everything is just going to be cleared and we will be left with nothing on the screen. So if you want to see this practically, I can put a delay before the clearing of the screen, so that at least we can see maybe about 2 seconds. It should hold that hello for 2 seconds before it should clear. So I'm restarting the simulation. Yeah, so counting 2 seconds on the screen right now is now 1 second. Then we have 2 seconds now. So after 2 seconds the screen clears. So this is good for certain projects. Maybe you are building a game, okay, you are building a game, then maybe the person dies, then after the person has died in the game, right, you print out the person's score, and you don't want the score to be there forever. So but then it should be there for the person to actually view it for some time. Oh, I had this was my score before everything clears. So that would be a use case of what I just did here. Okay, so again too, you can put in the print in the void setup is maybe you want to make the program or the project more interactive, right? You can say system loading, like just give it interesting words. So this is just a recap of what we've done so far. So system loading. Great. So exactly. So there's an issue here. This LCD is a 16 by 2 LCD. So it takes 16 columns and 2 rows, or it has 16 columns and 2 rows, meaning that it can only display 16 characters on a line. So let's count: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Right, but then it missed a gene. So you need to also know how many characters are going to be displayed. If not, which one will be at the end, or which one will be left out, so that I can make provision for it to come below. That's the mathematics here in the programming as well. So it's either you take out one of the dots from the beginning, right, so that you can have the full thing loading, or the full thing being printed out, or you maintain the dots, you cut the gene, then you implement something we call set cursor, or a method that we call set cursor. So coffee dot set cursor. All right, let me just all right, so we have a method called set cursor. Set cursor will take two arguments. The first argument is the column index. Remember arrays, so arrays doesn't do with like the normal placing of numbers, or like how you normally start counting from, but then it starts from 0. Okay, so it will take the column index, then we go to the row index. So if we have 16 columns for the LCD, 16 by 2 LCD screen, okay, if we have 16 columns, it means that the last index will be 15 and the first index will be 0. So and again, that's for the first line. And when we come to the rows, okay, rows just means the lines. Okay, so when we come to the rows, it means that the first row is 0, or has an index of 0, and the second row has an index of 1. So what we want to do is, still we are maintaining the first column, right? Then we are setting the cursor still on the first column, the first column, but on the second row, and the second row has index 1. So that's what we'll do, and then we'll come and print out this gene, okay, because the gene cannot fit on that line. So I'll put this there. Then we'll have coffee dot print, then I can print my gene now, because I am on a new line now. Great. So I'm going to run the simulation and see what happens. Great. So it got to system loading, but then with the N, and the line was full, and I set the cursor to column. This is column 1, this is column 2, this is column 3, 4, 5, 6, 7, 8, continuously. So that if column 1, but then it has an index of 0. This one is column 2, but has an index of 1. This is column 3, but has an index of what? Column 2. It has an index of 2, right? Then this line, the first line you see there, okay, looking at it horizontally, that is row 1, okay, but it has a row index of 0. Then the second line is row 2, but has row index of 1. So that's why I've put 1 here, okay, so that it will come and print here. I hope it's clear. Great. So we need to configure inputs. I think I gave an assignment, right? But then because of time, I won't, or I didn't give an assignment. Anyways, stop the simulation. Good. So we need to add a push button. All right, a push button such that we can be able to enter data or input data. You remember we've done the serial monitor already, right? And we're able to use the serial monitor to input data or some kind of number or text into the program so that it does some computations for us. But now let's say more or less we are building a calculator, okay, but at least we need to be able to um, give the user the opportunity to send in some data. So that's what we have next. So you add a new part or a new component. That's the push button. So you search for your push button. I'll use this one. Alright. So again, if you are not familiar with the push button, please get familiar with it, because there will be a lot of questions on that. Right. Thank you. So I can change the color of the push button, but then that's not for this class. So the push button has 4 terminals, as you can see, but then on a closer look you'd see that this and this are internally connected, aside this one and this one, just as I've explained to you already in our face-to-face classes, right? That you would see 4, but then when you turn the back, there is kind of like a line in the middle that is separating 2 sides from the other. So it means that if I make this side, let's get something right. So if I connect ground, okay, to this terminal, okay, it means that this terminal also is ground automatically, because if you watch closely, there's a faded line inside. That's for the simulator, but then in real life, when you turn the back, you should see like a line in the middle. So the left side of that, if you turn it for the line to face you vertically, the left side is separate. It's not fixed. So you can't say that, oh, it only takes negative. No, the push button does not have polarity. Or the right side will say it only takes the pin number or positive. No, you can change it anyway, so far as it is vertically facing you. Or let's say if it's horizontal, the line is horizontal, then the top part and the bottom part. You see, in this case mine is horizontal, so the top part and the bottom part. So I'll send the other terminal, which is not connected to the first one. That's why I'm using a different color of wire. Okay, to maybe I'll use pin 12. Right. So since I'm using pin 12, let me drag this push button down here. So basically what I want to be able to do is that I want to press this button, and whenever I press this button, some kind of data or whatever data I want to be displayed should appear on the screen. Very simple. So let me just rotate this. So this is my current setup right now. So basically if I press this button, something should be displayed. Maybe when I press this button, I want what do I want to be displayed even? Maybe a number, right? A number should be displayed, or some kind of message to be displayed. So maybe I'll say power on or something. So let's go back into the programming of this. Notice that we connected our push button, or I connected my push button to pin 12. So in the code, I'll just create an integer variable. Let's say btn. I'm calling it btn. You can call it whatever you want. So btn, and btn is holding 12, and that is the number or the pin number for the push button. So the pin mode is btn, because btn is now 12, then input pull up, right? So input, when you use input pull up, it means that you are using the onboard resistor, okay, the inbuilt resistor, pull up resistor, such that you forget all that I just said, such that when you use input pull up, when you press the button or when you push the push button, what will tell you that you have pushed the push button is that you'll be getting a signal of 0. And when you have not even pressed the push button, like when your hand is still not on it, what will happen is that you will just be getting signals of 1 1 1 1 1. I hope it's clear. Great. Yes, you're asking a question.
Yes, please. Would there be a case where we'll be like constrained to just use physical resistors, or will be allowed to like choose an option whether you use input pull up or you use the physical resistors?
What I am teaching you is what I'll be testing you on. I will not ask you to use physical resistors because I know that some people will destroy their boards. That's why I never made mention of it in class, even though the resources I shared, physical resistors are part. They also show the one I'm showing. Right, this is the easiest method because see, you just connect two wires. That's it. I mean, I hope it's clear.
Okay. Yes, please. Thank you.
Sure, great. So far, I hope all of you are understanding and you are moving along.
Yes.
All right, great. So, coming back to the word setup, we've set up pin mode, BTN, input pull up. That's great. So, I guess that's all we need in our void setup. So, we can do away with this. I will choose to comment them. I'll just comment them so that when I share this project with you, let me save it before I lose it. Group B tutorials. BC. Alright, so I'm just saving this project so that when I share it with you, you won't be confused. Alright. Yes, back to business. So now that we are done with our button, setting up our button to send input, and also setting up our Arduino board to receive input, we come into the void loop and we create a variable. Okay, you realize that the push button we are working with is either it has been pressed or it hasn't been pressed. Okay, so that reminds you of a kind of data type called boolean. So this time around we'll use something different, or we'll take a different approach. We'll store the signal into a boolean variable. So we'll call it bool is pressed, or okay, we'll just say bool val, or let me make it sound much better. So bool is pressed. Again, this is pressed, you see, it's just a variable name. Okay, so don't get confused. I'm also using camel casing. Bool is pressed, and what we want to do is we want to do a digital read. Okay, we want to do a digital read of what, the button. So we'll capture whatever signals that or data is coming from the button as at any time that we are getting it. So when we capture it and we store it into this variable called expressed, we want to first of all display it, and we will know whatever we are getting. So we'll say coffee dot print. Again, there's no print line in the LCD library I've shared with you, so if you use print line you are wrong. So coffee dot print, then I can print out is pressed. So in C++, whenever you see 0, it means false, and whenever you see 1, it means true. But then you realize that how do you call it? You realize that the signals that we are getting from the button, because we are using pull up, okay, pull up is at the top here, because we are using pull up, okay, whatever we are getting when we press will be 0, which means that is pressed false. So what you could do is that you convert it, okay, so it's either you convert it into the opposite, or you just simply change the variable name, so it's not pressed, so that when they don't press it, it means it's true, and when they press it, it means it's false. So it will mean something else, but let's just leave it as it's pressed. Okay, so we are going to read and store it into is pressed, then coffee.print is pressed. Then also let's just hold it on the screen for a while. So delay, so we'll delay for maybe 1 second, that's 1000 milliseconds. Then we'll clear the screen, so coffee.clear. Alright, so then we can go and run the simulation and see what we get. Okay, so I'm starting the simulation now. Right, so as you can see, I've not pressed the button, but we are getting 1. When I press the button, now I've pressed the button and we are getting 0. Do you understand? So this 1 and 0 thing that we are getting, it's 1, it means true, and 0 means false. So I want you to understand that again in maybe by using an if statement. Okay, so we'll maybe introduce an if statement underneath. So we'll say if, since it's a boolean variable, we can say if is pressed alone. What does this if statement do? What an if statement does is that it checks whether a condition is true or false. Okay, it checks whether this condition is true or false. So if the condition is true, whatever is inside here will run, and if the condition is not true, whatever is inside here will not run. Maybe if we include an else, then that condition will run. Hope you get it. So let's say else, just a simple if else statement. So if is pressed, rather we should display something. So let me cut from here and see coffee is pressed, so it should display. And you realize that I mentioned in the explanation that true is 1 and false is 0, but when we press our button we are getting 0, and when we don't press our button we are getting 1, which is true. Okay, so don't be confused about what I'm coming to say or what I am about to do. So not pressed. Right, then I'll bring the clear. Maybe I don't want to introduce so many clears, so I'll just put it at the end. Hope you are following. Then I'll cut this as well. No, I'll just paste it and paste one here. Then I'll print out this. pressed. Great. So now what we have in our code is that this boolean variable is storing whatever data that is coming from the push button as a digital signal, but then we know that digital signals are just zeros and ones, and a 0 is false and a 1 is true. And we also know that these are the things that we know. And we also know that when you press a push button, you'll be getting 0, and when you release it, you'll be getting 1. That's why when it's pressed, it's having a value of 1 is the same as it being true. Okay, true. So we know that it is not pressed. And when anything else apart from that, or let's say if it is, so okay, I'll go into that later. So let's go into our simulation and see what we have. Well, I'm going to restart the simulation, right? So you see, I have not pressed the push button, so I am getting not pressed, not pressed, not pressed. So if I am to come here and to click on this, right, the internet is here. So if I'm to come here and press on the push button, I get is pressed, is pressed. Once I release, I get not pressed. I hope you understand the logic, right? So I'll stop the simulation here. So that's basically it. Assuming that whole process is a confusing thing for you, what you can do is that whatever you are checking for in your if statement, right, convert it into its opposite. So right now we know that if it has been pressed, we are getting 0. So we are checking, instead of checking for true, we are checking for the opposite of true. That's why I've introduced this exclamation mark here. Okay, so then I'll change this to has been pressed, then I'll say still not. I think this is too long. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Okay, 16 is fine. Then I'll say still not pressed. Great. So let me launch the simulation again and we'll see what we get. 16. Okay, no problem. So when I press the push button right now, has been pressed, has been pressed, has been pressed. And when I release it, still not pressed. Okay, so that's type, it's called type conversion, right? So I have just converted, or I've changed what we are looking for, whatever we are checking for. Okay, because actually whatever we have here in the if statement, that's the exclamation is pressed, is going to be true when we are finding for the opposite of 0 or the reverse of 0, which is 1. So it means that it is true. Okay, so whenever you include the exclamation mark, okay, you are just looking for the not of something, or not of whatever is after it. So if I bring exclamation mark Akufo-Addo, I mean not Akufo-Addo. Do you understand? If I bring exclamation mark exclamation mark apple, I mean not apple. If I bring exclamation mark 0, I mean not 0, which is 1. Okay, great. So yeah, so again, if I want to So since we have that captured out, we want to print out a number when the user has pressed the button, right? So I'll just say 1. I want to display 1 whenever the user presses 1. Okay, I want to display 1. So coming back to my simulation, if I run the simulation, it says still not pressed. When I press the push button, then 1 is recorded. I've let go now, so that thing clears. Then it says still not pressed. There was an assignment I gave to the other class, which was that it should count and display the number of times a user has pressed the push button. Hope you get it. So that's what we're going to do right now. Then we move on to the next things. Then we are done for the day. All right. So I will, since I'll be sending you the video, I'll clean all of this. I'll clean all of this. So we need to keep a track of the number of times the user has pressed the push button. So we would say if, so this is very simple. So we say if the user has pressed the push button. In this case, it's either we use the not, or we use the creating another condition to handle when the user has not pressed it and all of that. So I think it's more efficient to use the not, the exclamation. So we say if not is pressed, but then we know that it has actually been pressed. Okay, so if not is pressed, again, let's come back to the top. When we come back to the top, let's create a variable to store the number of times the button has been pressed. So we'll say int, it's going to be an integer, so int num. So I'll just say int num, then maybe I'll initialize it to 0. So num has been initialized to 0. That this one is to store the number of times the user has pressed the button. Alright, so we're going to be storing that and we'll be updating. That's why we didn't do constant. I hope you're aware of this. You can do a constant int or a constant whatever data type, meaning that once you set this, nobody can change it in the code again, or after this nobody can change it in the code again, right? But then we are not using constant here, we are just using the int. So we are using num. So we can say that if it has been pressed, right, we should increase num. Since we are using 0, so we should increase num by 1. So num plus plus display num. So let's say coffee.print display num. Okay, so when we display num, let me just put num inside. So I've passed num into this print method. Okay, so whenever it has been pressed, then maybe add a delay. A delay of say 1. I think because of my internet speed, 1000 is too much, so I'll use 500 milliseconds. That's 0.5 seconds. Alright, so whenever we press, what is supposed to happen is that num is supposed to increase by 1 and display. Okay, and I'm not clearing the screen right now, and this is only when num has been pressed. If num has not been pressed, we don't do anything to it. So that was all the work I gave to them, and I even gave them 10 minutes. Which, how many minutes did I take to do this? 3. Right. So when I ran the simulation, okay, so I'm going to start the simulation. So starting the simulation, yes, I don't have anything on the screen. I'm not expecting anything on the screen. And when I press this push button 1, and when I press it again, okay, there's clear at the end of the line. Right, so 2, and I press it again 3, then it should clear actually, but that's not what I want. So I want you guys to see something. So I'm going to comment out this clear and start the simulation again. So when I press, I have 1. When I press again, I have 2 printed out in the next column. So again, if you don't use lcd.clear, it will start printing from the next available space. This thing has memory, so it can remember that, oh, I printed here, I printed. If there's no available space, that is when it will start printing from the first column. You understand? So the usual behavior of students is that, or what is supposed to be for students is that, while there is still an empty space in front of you, occupy the empty space. If there's no empty space in front of you, then you can go to the back. That's what it's supposed to be. But then let me just continue before I get problems. So pressing the push button again, and I get 3 printed out on the next index. So I'll press again 4, press again 5, 5, 5, 6, 6, 7, 8, 9, 10. So again, you see the 10, it doesn't take one index. It cannot print inside this small space alone, so it goes to add the next one. So let's see how the 11 will be printed. See, the 11 did not start printing here, but then it printed in the next one. So it just goes to show how smart the whole library is. Okay, so please don't go and use any other library apart from this library, because I have shown you this library. Alright, I'm going to end it. So let's make some further adjustments to the code. Right, so because we are dealing with space on the LCD already, space is something that is difficult to have. So we don't want to continue printing on the same line. There are some projects that maybe you want to still print on the same line, fine, but then we don't want to print on the same line. So when it updates the screen, okay, it should just clear lcd dot clear. Whenever you press, it should clear the screen. Whatever data is already there, or whatever has been printed, should be cleared. Then you increase, then you display. So the next time I'm coming to press again, whatever is there will be cleared. Then it will increase the count for me. Then I see my number, so it doesn't have to. Okay. So again, I went to do lcd.clear. Meanwhile, it does not identify anything as LCD. My child is called Kofi. When you look at the top here, okay, my child is called Kofi. So I'll fix that error now. So when I restarted the simulation, now we can start. So I press 1, I press 2, so the value changes in that same index. I'm coming, and I press 3, so the value has changed in that same index. And I press 4 again, 5, so it's changing within that same index. Yes. Who has the question? Yes. Any questions? Alright. If there are no questions, then I'm moving on. So again, it has been printed out in the same index or on that same position, right? So maybe to make this thing look nicer, maybe I can bring something in front of it. So I'll say coffee dot print, um, so print out um, say number. Yeah, for those who are not new to Flutter or who have used Flutter before, one of the very first example projects that comes with it is this application thing. It's an example application where there is a button and you just be pressing it and it updates the number of times you have pressed, and yeah, I think it's called counts. Yeah, so it's more or less this mimic of what you have. What's the error? Okay, so count. I did not end the line, so I'll start the simulation. Again, I will be doing this for the next we started at 9, so I'll be doing this for the next hour. But then if you want to go off, no problem, but then I'll make sure I send the video and everything. Okay, but then if you want to go off, there's no problem at all. Those who want to stay too, you can stay. Great. So I think I should end everything by 11 o'clock, right? So when I press the push button now, I have counts as 1. When I press the push button, I have counts changing to 2. When I press the push button, 3, 4, oh, okay, 4, 5, 6, 7, right? So it goes on and on and on and keeps track of whatever times you are on. So again, I can add another push button that will, you see, right now I'm passing it in as num. Okay, so assuming I want to maybe add something to the number before displaying it, so I can do num plus maybe 5, right? So whatever number of times we have, let's say in the beginning it starts at 0. Okay, so when I press the push button, the screen is cleared, num is printed out, so num is increased by 1, so num is actually 1 before it gets to what it has to be printed. Then when it gets to line 26, as you can see here, we are adding 5. Okay, we are adding 5 to the value of num already, so it will give us what, 6 instead of 2. So if I restart the simulation, I should be expecting 6. So when I press this button, exactly, I have 6. It's not continuing from what we did. Okay, it's just performing that computation you see number 5. So you could build a calculator. Okay, so you could maybe assign about some numbers. Okay, you can assign, let's say, 2 different numbers to 2 different push buttons. Then you assign an operator to another push button. Okay, so maybe you have 3 push buttons, then you have another one, maybe a 4th push button to do the computing. So when you press that 4th push button, then the answer will be displayed for you. Hope you get it right. So notice that I have not used the set cursor method, because if I wanted to, I can use the set cursor method. So all I can do is that